So the question is how to figure out if a number is rational or irrational. All rational numbers can be written in the form a over b. So our first example is written in that form, a over b, so it is a rational number. The next one is not quite as clear, 4 and 247 thousandths. But if you hear the way I say it, 4 and 247 thousandths, you can tell that we're going to be able to write this as a fraction. So I used a calculator and I changed 4 and 247 thousandths from a decimal to a fraction. If I can get it even in a mixed number, then it is a rational number. So 4 and 247 over 1,000 is in the form a over b. So yes, that is a rational number. Most of the numbers that we deal with are rational numbers. So I'm just showing that I converted from a decimal to a fraction using the calculator. You don't have to have a calculator that does this to do this lesson. How about 0? Is 0 a rational number? Is it in the form a over b? I could try 0 over 0. That seems like a logical first step to try 0 over 0. Because that is in the form a over b. The problem is we cannot divide by 0 ever in math. So that's not a possibility. So are we stuck? Or is there another way that we can write this? We still haven't determined if we can write it in the form a over b. How about 0 over 1? 0 over 1 is equal to 0. So we've written it successfully in the form a over b, and all we have to do is get it once, and it is a rational number. There are more ways that we can write 0. We could write it 0 over 2, 0 over 3. It doesn't matter. As long as we can do it once, then we've found a rational number. How about just a whole number, like 10? Can we write that in the form a over b? So 10 over what is equal to 10? 10 over 1 is equal to 10, so we just have to get it one time, and it satisfies the definition of a rational number. So yes, that was a rational number. Every whole number is a rational number. So 1, 2, 3, 4, any number you can count with. How about negative numbers? Yeah, those are rational numbers also, because we can write all the negative numbers over 1. We can put all these numbers over 1 and therefore make them into rational numbers, or prove that they are rational numbers. How about 3 and 968 thousandths? Yep, we can write that as 3 and 968 over 1,000. That's the same as 3,968 over 1,000. And so this is a rational number. Now be careful, I think I may have made a mistake here because the question says, is it irrational? So the answer should be no, and I think I'm about to choose yes because I didn't read it carefully. So I would have got that one wrong on IXL. The answer on this is actually no. It is not irrational. It's a rational number. So in the 8th grade D1, be careful to read the question carefully. Okay, how about the square root of 6? The square root of 6, if we change it to a decimal, does not convert to a decimal that repeats or terminates. And so there is no way to write it in the form a over b. We cannot write a fraction. Any fraction that we write is going to be an estimate or a rounded number. So this number is irrational. So there's no way to write a fraction for the square root of 6. How about the square root of 5? As you can see that I've converted square root of 5 to a decimal. I get 2.236079778. Notice after the 6 I get a 0, and then after the next 6 I get a 7. After one 7 I get a 9, after another 7 I get an 8. So there's no way to predict what's going to happen next, and it doesn't repeat and it doesn't terminate. So if it doesn't repeat and it doesn't terminate, there's no way for me to write it as a fraction, and so it is not a rational number. So here are some, oh, we've got one more, excuse me. So this is written as a rational number. It's in the form a over b. 1 over 3 is in the form a over b. So this is a pretty simple one. If we were to convert it, on a calculator, we'd see that the decimal is repeating. And we're going to see that on the next page. So repeating decimals are rational numbers. So here's some irrational numbers to memorize. Pi is a very famous one, 3.1415, and it keeps going, and it doesn't repeat, and it doesn't terminate. You don't have to memorize a lot of decimals of it, just that pi, the number itself, is irrational. Square root of 2, square root of 3, square root of 5, square root of 7. Notice that these are prime numbers. These are all irrational. These are not a list of all the irrational numbers, but just some good ones to memorize, especially for IXL. If you see these, then you know that these are irrational numbers. Examples of repeating or terminating decimals. 1/3 is repeating. The 3 keeps repeating, so we write it as 0.3 with a line over the top, and that is a rational number. 6/8 stops after the 5. You just get a 0 and 0 forever after that, so it stops at 75 hundredths. So we can write that as 75 over 100, which simplifies to 6 over 8. It's a rational number. 7/9, we'll just do 7 divided by 9 and see what happens. 7 divided by 9, it goes in 7 times. I make a mistake here and write 6 and realize, oh, that's only 54, that's not enough, so I'm going to change that to a 7. 7 times 9 is 63. And I'm going to show you how it repeats. There's 7 left over, so I bring down the 0, and so I use 7 again, and that's just going to keep repeating. So that is 0.7 repeating. And these are all rational numbers. All decimals that repeat or terminate are rational.